Galaxy mergers can occur when two galaxies collide. They are the most violent type of galaxy interaction. Although galaxy mergers do not involve stars or star systems actually colliding, due to the vast distances between stars in most circumstances, the gravitational interactions between galaxies and the friction between the gas and dust have major effects on the galaxies involved. The exact effects of such mergers depend on a wide variety of parameters such as collision angles, speeds, and relative size, composition, and are currently an extremely active area of research. Galaxy mergers are important because the merger rate is a fundamental measurement of galaxy evolution. The merger rate also provides astronomers with clues about how galaxies bulked up over time. Description: during the merger, stars and dark matter in each galaxy become affected by the approaching galaxy. Toward the late stages of the merger, the gravitational potential begins changing so quickly that star orbits are greatly affected, and lose any memory of the previous orbit. This process is called violent relaxation. Thus, if two disk galaxies collide, they begin with the stars in an orderly rotation in the plane of the disk. During the merger, the ordered motion is transformed into random energy. The resultant galaxy is dominated by stars that orbit the galaxy in a complex and random web of orbits. This is what we see in elliptical galaxies, stars on random, unordered orbits. Mergers are also locations of extreme amounts of star formation. The star formation rate during a major merger can reach thousands of solar masses worth of new stars each year, depending on the gas content of each galaxy and its redshift. Typical merger SFRs are less than 100 new solar masses per year. This is large compared to our galaxy, which makes only a few new stars each year. Those stars almost never get close enough to actually collide in galaxy mergers. Giant molecular clouds rapidly fall to the center of the galaxy where they collide with other molecular clouds. These collisions then induce condensations of these clouds into new stars. We can see this phenomenon in merging galaxies in the nearby universe. Yet this process was more pronounced during the mergers that formed most elliptical galaxies we see today, which likely occurred 1–10 billion years ago, when there was much more gas in galaxies. Also, away from the center of the galaxy, gas clouds will run into each other, producing shocks which stimulate the formation of new stars in gas clouds. The result of all this violence is that galaxies tend to have little gas available to form new stars after they merge. Thus, if a galaxy is involved in a major merger, and then a few billion years pass, the galaxy will have very few young stars left. This is what we see in today's elliptical galaxies: very little molecular gas and very few young stars. It is thought that this is because elliptical galaxies are the end products of major mergers which use up the majority of gas during the merger, and thus further star formation after the merger is quenched. Galaxy mergers can be simulated in computers. To learn more about galaxy formation, galaxy pairs initially of any morphological type can be followed, taking into account all gravitational forces, and also the hydrodynamics and dissipation of the interstellar gas, the star formation out of the gas, and the energy and mass released back in the interstellar medium by supernovae. Such a library of galaxy merger simulations can be found on the GLMER website. A study led by Jennifer Lotz of the Space Telescope Science Institute in Baltimore, Maryland, created computer simulations in order to better understand images taken by the Hubble telescope. Lotz's team tried to account for a broad range of merger possibilities, from a pair of galaxies with equal masses joining together to an interaction between a giant giant galaxy and a puny one. The team also analyzed different orbits for the galaxy's possible collision impacts, and how galaxies were oriented to each other. In all, the group came up with 57 different merger scenarios and studied the mergers from 10 different viewing angles. One of the largest galaxy mergers ever observed consisted of 4 elliptical galaxies in the cluster CL0958 plus 4702. It may form one of the largest galaxies in the universe. Classifications. Galaxy mergers can be classified into distinct groups due to the properties of the merging galaxies, such as the number, the comparative size and the gas richness. By number binary merger, 2 interacting galaxies cause the merging. Multiple merger. The merging involves more than 2 galaxies. By size minor merger, it occurs when one of the galaxies is significantly larger than the other. The larger galaxy will often eat the smaller, absorbing most of its gas and stars with little other major effect on the larger galaxy. Our home galaxy, the Milky Way, is thought to be currently absorbing smaller galaxies in this fashion, such as the Canis Major Dwarf Galaxy, and possibly the Magellanic Clouds. The Virgo stellar stream is thought to be the remains of a dwarf galaxy that has been mostly merged with the Milky Way. Major merger. It takes place if 2 spiral galaxies that are approximately the same size collide at appropriate angles and speeds. They will likely merge in a fashion that drives away much of the dust and gas through a variety of feedback mechanisms that often include stage, in which there are active galactic nuclei. This is thought to be the driving force behind many quasars. The end result is an elliptical galaxy, and many astronomers hypothesize that this is the primary mechanism that creates ellipticals. One study found that large galaxies merged with each other on average once over the past 9 billion years. Small galaxies were coalescing with large galaxies more frequently. Note that the Milky Way and the Andromeda Galaxy are thought to collide in about 4.5 billion years. The merging of these galaxies would classify as major as they have similar sizes. The result would therefore be an elliptical galaxy. By gas richness wet merger, it is a merger between gas-rich galaxies, or blue galaxies. Wet mergers may produce a larger amount of star formation, transform disk galaxies into elliptical galaxies and trigger quasar activity. Dry merger. It takes place between gas-spore galaxies, or red galaxies. These mergers may not affect the star formation rate heavily but can play an important role in the stellar mass growth. Damp merger. A type of merger between the 2 mentioned above, where there's enough gas to fuel significant star formation but not enough to form globular clusters. Mixed merger. It occurs when gas-rich and gas-poor galaxies, or blue and red galaxies, merge. Examples. Some of the galaxies that are in the process of merging or are believed to have formed by merging are Antennae galaxies, Mice galaxies, Centauri,